Thank you for being with us. My name is Redouan Kara, IoT Manager at Integral System. Today, we're together for a podcast that will talk about IoT, data collection, and predictive maintenance. And to introduce the company, Integral System sells industrial computer hardware, rugged PCs, fanless PCs, rugged tablets. We have a section that does custom development, web, mobile, and we've also been doing IoT for a few years now. We sell off-the-shelf solutions, but we also do custom work for our clients. I'm lucky today to be with two experts in their field, Stéphane Blanc and Alexandre de Combejean, and I'm going to invite them to introduce themselves right away.
Thank you, Redouan, for the invitation. So let me introduce myself, Stéphane Blanc from Advantech. I am Sales Director for Southern Europe. I've been working at Advantech for about 18 years. We work in vertical markets, transport, industry, machine manufacturing, and energy. And for these markets, we have different types of products. So Advantech is well known in the world of industrial PCs. We have everything related to data acquisition, everything related to communication, and everything related to visualization, let's say, machine interface. Alongside that, Advantech has been working in industrial IoT for many years, specifically for everything related to data collection, information retrieval, and dashboarding. And it's on this topic that we're going to dive into today with Redouan, where we'll be able to share our insights and present to you
how Advantech can, in collaboration with TCT, bring you solutions. Hello? Thank you to Integral System for the invitation and to Redwood for inviting me to participate in this podcast. I am Alexandre Combejean from the company TCT. I have been the sales and marketing manager at TCT for almost 7 years. Now, TCT, we are a French company specialized in the manufacturing and development of electromagnetic solutions. Our core business is to manufacture magnetic cores. We are one of the last to do this in France. And we manufacture standard mode current transformers and power electronic components. And recently, a newcomer has arrived in the world of IoT as we have developed a dedicated solution for this market. And I am delighted to participate in this podcast to discuss this exciting and important topic for our industries.
Today's topic is data collection and predictive maintenance. The first part is really going to be how can we collect data on production lines, in workshops, in factories, etc. With what equipment, with what software, and with what network protocol as well. That could be interesting. The second part will be more focused on predictive maintenance and artificial intelligence. And the last part will be a bit of a general conclusion. So, Alexandre, can you explain to us what type of machine do you have in the factory? What type of sensor have you installed on it? And how do you use that data to work?
So I would say that the first one is the one that's a bit more critical, the one we think about the least, the compressor. Because we have a huge need for compressed air. It's something that wasn't monitored at all before. And now, thanks to the sensor, we measure the current, the temperature on the motor, plus the vibration. Not long ago, it allowed us to see that the compressor was decreasing in terms of productivity. And so maintenance was able to intervene. In fact, my maintenance team was the most amazed by the usefulness of the solution. To get back to your question regarding the machines, we have what we call winding machines, which allow us to wind the magnetic cores. Actually, it's mechanical. We have a membrane. And we wrap the magnetic tape around these products. In the process behind it, there's a big element, which is that a magnetic core, to give it electromagnetic properties, needs to be baked. So we have 6 heat treatment furnaces with processes that can last 8 hours of cycle and go up to 1200 degrees. So these are electric furnaces.
You don't put sensors in furnaces, no.
The sensors are not in the furnaces nor in the cabinets, but the cabinets are behind the furnaces. So we are still in a real industrial environment with heat. We can have temperature rises in this area, which can easily reach around 40 degrees, especially in the summer, even a bit more. And these furnaces are really big power consumers for us. Here we are dealing with 3-phase power, so we installed the sensors in groups of 3 on each phase. And with the WISE-IoT the dashboard system, we were able to actually combine these 3 sensors to perform 3-phase analysis.
Your sensor is a current sensor that captures the current intensity.
Exactly.
In single phase.
Yes.
And we put one per phase, and in the software, you can create a visualization that allows you to...
Exactly. We created a visualization where we can see each phase independently, and then we have a total of the phases with a calculation behind it. And so that's where the point is important. In the office of the Industrial and Production Service, we have a monitoring screen where we run software to see the actions, maintenance, the things we have to do, and we have the WISE-IoT dashboard up there. And my production manager tells me it's so convenient because it allows me to see which furnaces are running at that moment. So we're not talking about measurement or analysis or anything like that, but with just a glance from her office, she can see that it's furnace A, B, C. That's running, and she has a bit of an idea of where things stand. Sometimes it can alert her, hey, furnace C should be running, it's not running. What's going on? I'm going to check, and there's no maintenance issue or anything, but it's just a production problem.
I just want you to introduce us to the technology. I'm installing the sensor at the same time.
So it's a current sensor. So you can maybe open it to show the basis of our core business, the magnetic core. So there's something inside. So the advantage of this sensor is that it works without batteries and without a power source. We're not magicians, it's technology. Every electrical cable emits a magnetic field. Usually we capture this magnetic field to measure current or for differential protection. And here we capture that magnetic field, generating an electric voltage to power some electronics. This makes the product completely autonomous. And you don't have to think in 5 to 10 years, oh, I need to change the battery or the power source. A lot of these sensors are in cabinets. It's still complicated to go and touch the cabinets. There are sensors that we've really placed in hard-to-reach spots, especially for the furnaces where the products are mounted directly on the sensor paths, because we also wanted to see the aging of the product. So the benefit is really there. This product can be installed anywhere in just 2 seconds, actually. There it is. It's non-inclusive, non-destructive.
A big advantage, I think, is during the testing phases, for example. If you need to run tests and check information, you can take your sensor, you place it in a specific spot, you check, you reinform, and you change.
That's right. We can run measurement campaigns for a week, a month. It's really the flexibility of the product and the fact that it's paired with a gateway. Well, our gateway belongs to a large group. On the IT side, it's complicated because you have to request permissions to unlock the gateway. We struggled a bit with that. We've switched to a super autonomous 4G gateway.
Indeed, either we have a gateway that can hold a SIM card inside and we can connect directly, and having access from the outside, for example, over the internet, knowing that you need to protect yourself with VPNs, things like that, to set up afterwards. There are solutions at Advantech that can address that. And then the other solution is indeed to have an external industrial router, so either 4G, make it, or 5G. But in any case, this router will allow you to have your devices that are in the factory, which will be accessible from the outside. And all these routers, if you have, for example, several factories remotely, we have a tool called DMP, which allows you to monitor these routers and manage them a bit from a distance.
We got a pay-as-you-go 4G subscription, so it's someone from the study course who tops it up each time. I dedicate this moment to my colleague Thierry, who is indeed a bit older and who set up the prepaid cards for managing the industry. So thank you, Thierry.
I can't specify about the router, then Advantech, they are industrial routers. That is to say, we are really a company that focuses on industrial hardware in general, regardless of the market, as I mentioned. And that's what allows it to be installed in a factory. One might think, hey, I'm just going to the local store to grab a public router and it'll work. But on the other hand, the sustainability, because the product after 2 years won't be on the market anymore and there will be another one. So if it needs to be changed, there might be some things to put in place. With Advantech, there will be a much longer lifespan and also the robustness expected in terms of vibrations, temperatures, and so on. These are the major advantages of industrial solutions.
Clearly in the factory, that's what defines it. And to get back to your question about the machines, we're not done yet. We've made the compressors, we've made the winders, we've made the ovens, which are big consumers, drawing about 70 to 80 amps per phase. So it's running quite a bit. Then we have other processes, and we have a cutting process in particular, specifically for cutting the core of this product so that it becomes an opening product and thus easier to install. And here, we have a machine that we developed specifically to handle the cutting of magnetic cores. So it may seem simple, but it's extremely complicated because when you cut a magnetic core, it destroys its electromagnetic properties. And we need to have a cut, what we call an air gap, that is as perfect as possible. So we invested in a machine for that. So it's a critical machine. It's really a critical machine with a robot that takes the cores and automatically puts them inside. A machine that operates between 8 and it also runs at night when no one is around. And it's an element that we need to monitor. And there are also the pump motors of liquid cooling, things like that. These are things that we don't necessarily have in stock, in maintenance, and where there's a bit of a delay in getting them, things like that. And actually, this specific equipment, we equipped it with the TCT sensor, but we also equipped it with the Advantech vibration sensor, which is mounted directly on it. And that really allows us to do monitoring and, I would say, predictive maintenance of this component so that we can generate and anticipate the replacement of the critical components of this machine.
You're right to bring it up because it allows me to segue into what's next. I'm going to ask you some questions and I want your opinion. What type of sensor can we use in the situations I'm going to outline for you? For example, if I want to capture the energy consumed and the temperature inside a paint booth, then you respond,
the TCTD sensor. The TCTD sensor, it's good.
I think the game is understood now.
There's a name that it goes by, the E-green sensor.
It's called the E-green sensor. Anyway, we're going to embed it. We'll put everything that's needed for people to recognize it very easily. If I want to collect the ambient temperature and humidity data from a room,
I have the intention. At Advantech, we have a product line called EVA 2000, which uses LoRaWAN and allows us to collect this type of information. The first solution, otherwise, is with modules from the WWISE range, WWISE 4000, which also allow for this type. There are built-in sensors. And the last solution, otherwise, is modules from the Adam range, products that are quite well known, a bit blue, which we often see in the industry, but they do require having connected sensors underneath. So here we're going to install 420 millimeter type sensors with a temperature sensor. For humidity, it will be a bit different, but there you go. It's this type of product that will meet that need.
Detecting potential water leaks on pipelines, for example.
It's the same range as the one I mentioned earlier, the EVA 2000 range, which is quite recent because we actually have a liquid leak sensor. So how actually...
It's something that is generally adhesive. You place the surface where you want to check for leaks. And if a drop of water passes between the two, it closes the circuit, sending a signal. So that's how it's done.
At home, just a quick return to home automation, there are sensors. You can place it, for example, near your dishwasher or washing machine, and when it leaks, it's the same principle. There are 3 little pins. It connects to me. That's what needs to be added. But not industrial. This is industrial.
If I want to track the operating times of the machines,
I would say there's a current sensor that allows you to see how the machine is operating.
or they are thermal engines.
Well, thermal, I think we're probably going to have some vibration or heat. So, vibration sensor or temperature sensor.
An on-off sensor too, I think you might have that.
I think all these elements and all these sensors are the key components for the future. Because the industry and large companies particularly ask their subcontractors to estimate the manufacturing cost, not the cost per piece, but the operating cost of a machine. And I have a use case with a client who works for a well-known ERP software that wants to use these sensor readings to integrate the data directly into the ERP so that they can be measured and define a manufacturing cost within the system directly.
All of this is what we call OEE, overall equipment effectiveness, or in French, TRG, taux de rendement global. This type of information allows us to analyze all the operating times, to be able to optimize and indeed calculate the cost. Real. And just so you know, in the future, WISE-IoT, we have the vibration solution we talked about. And we also have solutions to perform this type of analysis.
We had already seen that happen with Wi-Fi. We're increasingly moving towards wireless, with sensors that are non-intrusive, no need for wiring.
It's not for nothing that our product was developed around LoRaWAN. As you mentioned earlier, it's a protocol that consumes very little. And we are using an energy harvesting system through induction. So energy harvesting, it's too power hungry actually. So the Party LoRa actually allows us to reduce consumption and then send the sensor to store data. And it sends this data from time to time.
How often do you send the data up? It depends on the use cases.
It's configurable, but in the use cases, we're usually between 10 and 15 minutes. And by the way, how can you configure the data on your sensor? Because the sensor is configurable via a BLE application using Bluetooth. And that allows us to configure because we realized with an Android or Apple app, and that allows us to configure it remotely. Because we realized that each client has different cases, has different needs. At first, we started with something fixed. We quickly stopped and said, we need to do something more flexible and adopt that. Because some of them send us data every minute. Just to clarify, our sensor, you mentioned billing. It's not a billing sensor. It's not a certified sensor. MID, the standard precisely that allows for rebilling. But there you go. There are some cases that require that. And I think a large part of industrial cases require frames that are larger. And the LoRaWAN network is completely suited for that.
When we talk about distance, we're even talking about several kilometers. Well, in theory, we can say 15 kilometers without obstacles, but that's really just in theory.
We were surprised when we did the setup in the factory. The gateway was at one end of the factory, and we have one of the products, so another one of the machines that we haven't talked about where we do molding. And there, the sensor is in the pump housing that allows for creating a vacuum in the machine. This motor is really encapsulated in a metal structure to reduce noise. It made a sound. It's a big metal structure. It's really a paradise cage. Everything is locked, and we said, this isn't going to work. No problem at all. The gateway connected right away. The power, it's really...
To clarify, Alexander is talking about the vibration sensor. He's talking about the 2410. To conclude this part on data collection, we offer all the pre-configuration of the equipment. That means when we deliver the sensors with the gateway, everything is already paired. The gateway just needs to be powered up, the sensors just need to be installed, and everything communicates. Then everything happens on the software. The software comes with technical documents and is still very easy to use. So after...
I use it as a manager, sales and marketing. At all the trade shows, I have my tablet connected and I show people the factory in operation live. And honestly, it hits the mark. But what's interesting in what you're saying is that this pre-configuration will open up new markets. In the world of IoT, by attending a lot of trade shows, there are still plenty of people who don't know about the LoRa network. The R1 doesn't mean anything to them. It's not something they know. And actually, when we ask the question about what they work on, it's mostly small and medium-sized enterprises. And these are people who don't think about using these sensors. IoT, the fact of selling them pre-configured and basically giving them a turnkey tool where they just have to connect it through their RJ45 or via a 4G or 5G card, it opens up new market shares and gives these SMEs access to much more precise measurements. And I think that's interesting, to sell a packaged, complete and simple solution.
What's also interesting is that Integral System offers you distribute our products and you provide a starter kit. It's a kit that you have defined with different sensors inside. And the advantage is that a client, whether it's a small or medium-sized enterprise or something else who needs to test, will be able to take this starter kit, will implement it. He will have direct access to different data. Everything will be ready. So say everything is pre-configured, everything is predefined in terms of product. It's a package. You receive the box, you unpack it, you install it, and it's operational.
That's great because you allow me to segue and make the introduction. With the second part of this podcast, the predictive maintenance part, we indeed have a predictive maintenance starter kit that allows you to monitor your engines. I suggest we take a short break and then we'll get back to the predictive maintenance part.